Hello again, welcome to another lesson in geometry. Today we're covering section 7.2, similar polygons. And you might have learned about similar polygons back in Math 8 or pre-algebra somewhere where you'd solve proportions to find the missing sides. So let's see what's going on in this section. All right, so what does it mean when two segments are congruent? It means that they have the same length. And what does it mean when two angles are congruent? It means they have the same measure. Okay, so both are like 30 degrees or whatever. So they have the same measure. Okay, so same length, measure it with a ruler, they should be the same how long they are. And for angles, they have the same measure, so measure it with a protractor, they should have the same degree measure. All right, so measure each segment and then circle the congruent segments. So if you pull your ruler out and measure them, you should find that this one and this one are the same. So the second and the third look pretty close, but the second and the fourth look pretty close, but the second and third are the same. All right. So we have a vocabulary builder here, similar. Other words for forms, similarity is a noun and similarly is a adverb. Definition, things that are similar are alike, but they're not identical. So they look alike, but they're not the same. So our math usage here is figures that have the same shape, but not necessarily the same size or similar. So there's some scaling factor between them that makes them different. So it changes the size of it, but it keeps the same shape. Okay. So how are the two squares at the right similar? Well, they have the same angles. And all sides are congruent, right? Okay. So that's what makes them be squares. So for the small one, all the sides are the same and all the angles are 90. And for the big one, all the angles are 90 and all the sides are the same. How are these not similar? Well, the one is bigger. Okay. So for similarity between two shapes, all the angles should always be the same, and then the sides should be proportional, which means there's some constant that I could times by one of the sides to make the other one, and then that same constant would work for all the other sides. Okay. All right, so similar polygons. Two polygons are similar polygons if corresponding angles are congruent. That's what we were just talking about. So in the squares, all the angles were all 90. And if the lengths of the corresponding sides are proportional. And we'll talk a lot more about this one down below here. So A, B, C, D, and G, H, I, J are similar. So this little squiggle without the equals we saw already with the word similar is how we pronounce it. So draw a line from each angle in column A to its corresponding angle in column B. So angle A was this right angle down in the bottom corner, and angle G is its corresponding angle in the big one. Angle B was the right angle in the top left here, and it's going to be corresponding with H. Okay. Now the big one could have been turned around or even flipped over, and we would still have to find the matching ones. Okay. So C is going to match with I, and D is going to match with J. All right, so complete the extended proportion to show that the corresponding sides of A, B, C, D, and G, H, I, J are proportional. So AB should correspond with CH, or GH, sorry. And then BC should correspond with HI. And IJ is over here, so that's going to correspond with CD. And AD is down here, and that's going to correspond with GJ. Okay. So if we were to find the lengths of all those sides and divide each one of them separately into these little pieces of a proportion, all of the ratios would be the same. Okay. All right, so understanding similarity. Problem number 1 here. DEFG is similar to HIJK. So we have two quadrilaterals that are similar. What are the pairs of corresponding angles, and what is the extended proportion for the ratio of the lengths of the corresponding sides? All right, so angle D is going to be matching with H. They're both in the first position. E is going to match with J. K is going to match with F. They're both in the third position. and L is going to match with G. They're both in the last position. All right, complete the extended proportion. So DE goes with HJ, that's for sure. Those are the first two letters in each of those quadrilaterals. EF is this middle two, so they should go with JK. KL is the last two, so they should correspond with FG. And we need one more here, so I think we don't have DG on here. So let's go with DG, and DG goes with HL. All right. So a scale factor is the ratio of the lengths of the corresponding sides of the similar triangles. So the scale factor is found by doing either one of these. So divide any one of those, and that'll be equal to your scale factor. Okay. So that's our ratio. Problem number 2, determine similarity. Are the polygons similar? If they are, write a similarity statement and give the scale factor. So circle the short sides of each rectangle and underline the long sides of each rectangle. So since they're rectangles, we know all the short sides are the same. So the short sides are KL, NM, or MN, let's see, XY, and WZ. And then the long sides are all the others. Okay. All right, so let's find out the ratios, comparing them. So KL to XY. KL to XY is going to be 10 to 15. Okay, and then that would reduce to, 2/3, right? Okay. And then LM to XY, that would be 15 to YZ is 20. So that's right here. And if we reduce that, we get, let's see, 5 goes into each one of those, so 3/4. And then MN is 10. And ZW is also 15, so that reduces to 2/3. And NK is 15. And this one's going to be 20, so this will reduce to 3/4. Okay. All right, place a check in the box if the statement is correct. Place an X if it is incorrect. So the scale factor is 2/3. No, because it wasn't 2/3. Some of them were 2/3, but other ones weren't. Scale factor is 3/4. No, because some of them were 2/3. The polygons are not similar. Check. Okay. So these polygons are not the same. They're both rectangles. They both have right angles, so all the corresponding angles are the same, but unfortunately our sides are not proportional. The sides for the short ones are proportional, and the long ones are proportional because they're the same length for each one, but together all of them do not make the same number. So we have some 3/4 and some 2/3. So our final answer is no. Okay, the polygons are not similar. Okay, problem number 3, using similar polygons. So ABCD is similar to EFGD. What is the value of Y? Okay, so circle the sides of ABC that corresponds, or the side of ABCD that corresponds with EF. So EF is this little one here where Y is, and then that trapezoid, so that's going to be that one up there, AB. Okay. Use the justifications at the right to find the value of Y. So EF is the same as AB, and ED, which is 6, is the same as AD, which was 9. Okay. All right, so that's where the 6 and 9 come from here. ED was 6 and AD was 9. Those are two corresponding parts of our polygons. And Y corresponds with 5. The length of AB is 5. All right, so here they have the small polygon on the top and the big polygon on the bottom in both of our ratios. All right, so we'll do the cross products. We'll get 9Y equals 30. And then divide both sides by 9, and you get 3.3 with the bar, or 3 1/3, or you could even write that as 10/3. Okay. All right, problem number 4, using similarity. So a rectangular poster's design is 6 inches high by 10 inches wide. Okay, so 6 by 10. What are the dimensions of the largest complete poster that will fit in a space that is 3 feet high by 4 feet wide? All right. So we want ours to fit in a 3 feet by 4 feet. All right, so 3 feet is actually, well, let's see what they're doing in the problem first. So 3 feet is 36 inches. So that's 3 times 12 for 36 inches. And 4 feet is going to be the same as 48 inches. Okay. And then we have up here, 36 inches divided by 6 will give us 6 that will fit in there. So we could take this and make this 6 bigger. Okay. And over here we have, let's see, 48 inches divided by 10 that away will give us 4.8 sideways that will fit. Okay, so the design can be at most 4.8 times bigger. Now it can't be the 6 bigger, because if we make it the 6 big, then this way would be 60 for this length, and that would be too big. So if we make the 10 become 4.8, then the 6 will be 6 times 4.8, which is smaller than 36. So it'll still fit in the up and down part. Okay. All right, so let x equal the height of the poster, write a proportion, and solve for the height here. So we could do 10 to 48. This is the little to the big again. And let's see, we get 6 here. So the up and down little one, so we don't know the up and down big one. That's the one we're going to have to solve for. Okay. All right, so then we could get our cross products to get 10x equals 288. If you multiply 6 times 48, divide both sides by 10, and we get 28.8. Okay. So the largest complete poster that will fit is 28.8 inches by 48 inches. Okay. So we make the width of the poster be 48, so the 10 turns into 48, and then the 6 to make it work with it would be 28.8. All right, let's flip it over and take a look at our last page here. All right, so problem number 5, use the scale drawing of the bridge. What is the actual height of the towers above the roadway? All right, so we have this scale drawing, and in our scale drawing, 1 centimeter of the drawing is supposed to be 200 meters in real life. So use the centimeter ruler to measure the height of the towers above the roadway in the scale drawing. Okay, label the drawings with a height. So from the above the roadway to here is going to be about 0.8 if you measure it with your centimeter ruler. Okay, identify the variable. Let h equal the actual height of the towers. Okay. Use information in the scale drawing to write a proportion, and then solve to find the value of the variable. So here's our hint. We could do the scale factor that was given to us here, this scale, to help us with half of our proportion. So we have the, the drawing to the real thing. All right, and the drawing is 1 centimeter to the real 200 meters. And our drawing, what we're looking at, was 0.8 centimeters to our actual height, h. Okay. All right, so we'll do our cross products. 1 times h is h, so this solves automatically as soon as I do my cross products, and we get 160 when we multiply the other ones. Okay. So the actual height of the tower above the roadway is 160 meters. Okay. All right, lesson check here. So as always, pause the video, go through this and see if you can match up the triangles correctly, and then come back and we will check it over. Okay, welcome back. The triangles at the right are similar. What are the 3 similarity statements for the triangles? All right, so the triangles are ABS. And let's see, so A had the 1 mark, B has the 2 mark, and S is in the middle. So P has the 1 mark, so P's got to go first, and then R, and then S. So angle A corresponds with, or is congruent to angle P. Angle B is congruent to angle R. And angle S is, of course, still congruent to angle S. Those are supposed to be our vertical angles that are in here. Okay? All right, so triangle ABS is going to be congruent to triangle PRS. That's our original one. And then BSA, so that took the second and the third moving around, so just changing the position. So they move the A to the end here. So over here we have to move the P to the end, so this will be triangle RSP. Got to keep the corresponding pieces together. So A and P should always be in the same spot. And then SAB, let's see, so S always went with S, and A was supposed to go with P, and B goes with R, so SPR. Right? So this completes our lesson for today. Check off the vocabulary words that you understand. So similar should be pretty good by now. Extended proportion, that's a weird way of saying, make each one X, and then we can use it to help us solve it. Okay. Scale factor, that's what we're looking for between two similar things. So like up here, what would be the proportional scale factor between the small one and the big one? And then a scale drawing. Okay. So the scale drawing one I think was pretty easy to do. You probably did that one in Math 8. This one was a bit trickier here because you had to figure out how wide or how deep could you make it, how tall. You had to decide that first before we could solve the proportion to find the missing one once we decided how wide or how tall to make it. Okay, so you might want to go back and watch that one again if you need to. And then hopefully you should put you somewhere in this 8 to 10 range for how well you can do this. All right? I'll see you in class next time.